Example from uniform distribution defined over 0 comma theta, where x1 is minimum order statistic and xn is maximum order statistic, then the covariance of xn and x1 by n xn is. So we are having this x1, x2 and so on xn follows uniform 0 comma theta IID random variables, and we have x1 being the minimum order statistic, x1, x2 and so on xn, and similarly xn the maximum order statistic is x1, x2 and so on xn. So we need to find what is the covariance of x1 comma x1 by xn. So for that, so first by using the covariance definition, so I can write this thing as expectation of x of 1 into x of 1 by x of n, sorry x of n. So we need covariance of x of n and x of 1 comma x of n. So this will be x of n minus expectation of xn into expectation of x1 by xn. So that means this will become expectation of x1 by xn. So that means this is nothing but expectation of x1 minus expectation of xn into expectation of x1 by xn. So we have expectation of x1, like since this is following uniform 0 theta, so that means x of 1, so expectation of x of 1 will be theta by n plus 1, and similarly expectation of xn will be n theta by n plus 1, and we have like x1 divided by xn. This follows beta distribution with 1 n minus 1 parameter, since x1 is following uniform distribution. So that means expectation of x1 by xn will just be 1 by n. So that means our covariance will just be expectation of 1, so x1, which is theta by n plus 1 minus n theta by n plus 1 into 1 by n. So that is nothing but theta by n plus 1 minus theta by n plus 1, which is nothing but 0. So therefore it will be option A, or else like we can directly see that we are having like xi follows uniform 0 comma theta. So we know that x1 by xn is independent of xn in case of this uniform, so that's why like covariance is 0. So therefore like option A is the correct answer.